Okay, so we're going to use the guess method again with solving equations on this worksheet. Some of these equations are kind of challenging, but I'm going to change some numbers and just follow along as I work through it. So we are going to use the guess method. So G is given, U is our unknowns, E is our equation that we're going to use to find our unknown, S is you're going to substitute your givens into your equation, and then last S is solve, so you're going to solve for your unknown equation. So our first problem is one of the fastest humans on Earth can run 100 meters in 10 seconds. How many meters can he or she run in 45 seconds? So you are given his speed, 100 meters in 10 seconds. You need to find out how many meters, and you know that this happens in 45 seconds. So in doing that, you're going to put your G, U, E, S, S. So you're given your speeds, your velocity, which is 100 meters in 10 seconds, so meters per second, and then your time, which is 45 seconds. Oops, sorry. Your unknown is your distance. Your change in x, we do not know that. So going on to our equation, we're going to use change in x equals our velocity times our change in time. So we're going to get 100 over 10, which is the same as 10, you guys. So you can just type that into your calculator, times 45. This is going to give you 450 meters, which is your answer. Okay, moving on to the next one. This one I am going to change some numbers on it because it is kind of confusing. So we're going to change 0.3. We're going to change this to 0.3 hours. 0.3 hours. And we're going to change this feet to miles. So in doing this, Lainey takes her eye off the road for 0.3 hours. She adjusts the dial on radio. If she is traveling 60 miles an hour, how many miles will her car travel as she adjusts the radio? So we're going to use our guess method. G, U, E, S, S. So we're given our time, which is 0.3 hours. And we're given our speed, which is 60 miles an hour. So we have to find our distance. So we're going to do our change in x equals our velocity times our change in time. We're going to substitute. Our velocity is 60 times 0.3. And you are going to get 21 miles. As your answer is M. So that is how you solve for that one. So you're solving for distance on number 1 and number 2. Moving down to number 3. Okay. First one to help you do this. First, 5 minutes is equal to 0.083 hours. That'll help you in keeping your units the same. So you are heading towards Hollywood Theaters to catch a 4:50 show. You are still on the other side of town, and the movie is going to start in 5 minutes. If the movie theater is still 5 miles away, at what speed will you have to travel to get to the movie on time? Will you exceed the speed limit of 30 miles per hour, putting you in danger of receiving a ticket? So we first have to find out our speed. So if we're given our time of 5 miles, and we know that we have 5 minutes or 0.83 hours to get to the movie, we have to calculate our speed, and then we compare it to our speed limit of 30 miles an hour, and we have to see, are we putting ourselves in danger or not? So in looking at this, we do our guess method again. So your change in x is 5 miles. Your change in time is 0.083 hours. Your unknown is your velocity. So we're going to calculate velocity equals our change in t over our change in x, which equals 5 divided by 0.083. So our speed is going to be 60.24 miles an hour. So if you can't tell, yes, you will exceed the speed limit. Scratch that in. So that is the first part of that question. So you will exceed the speed limit because you're going 60 miles per hour. So you're going pretty much double the speed limit. On the last one, so this goes along with this question, so you kind of have to keep some of the information from above in front of you too. If you traveled at a speed limit, so your speed limit is 30 miles an hour, how long would it take you to get there? So if your speed limit's 30 and you know you're going 5 miles because, that's how far away the movie theater is, we're going to use our guess method. So we are given our velocity of 30 miles an hour and our distance of 5 miles. So we are trying to find our change in t. So our change in t equals our change in x over our velocity. Change in x is 5 miles. Change in our velocity is 30 miles an hour. So we get a time of 0.17 hours. So that is how you answer that one. Okay, moving on to page 2. Okay. So on page 2, we have a lot of calculations on this one, so you're going to have to bear with me. So it says Michael Phelps and his teammates won 8 gold medals at the 2008 Olympics. Examine the events and times listed below. Teams for events are for the whole team. Rank his or the team's speed in different events for the fastest to slowest. Use the columns in the table for calculations as needed. So what we're going to do in each one of these, you have to be aware that this is 1 minute and 54 seconds. So I would suggest if it says 54 seconds and 1 minute, you're going to add there's 60 seconds in a minute. So you're going to add 60 seconds to 54 seconds to get your total time in seconds. So your first one, 200 meters and 1.54 seconds. So we went 200 meters. And I'm going to divide that by 1.54 seconds, which is equal to 145 seconds. So I added 60 plus 54 to get that answer. And that gives me 1.75 meters per second. Next one, the men's relay is 100 meters, or the men's butterfly is 100 meters in 50 seconds. So I'm going to do 100 divided by 50 equals 2 meters a second. Next one is the men's butterfly. So on the men's butterfly, they went 200 meters in 1 minute and 52 seconds. So I'm going to take, in 1 minute, there's 60 seconds. So I'm going to do 60 plus 52. That's going to give me 112. You guys, I did that first one wrong. I'll do it again. So you get 1.79 meters per second. Going back to that first one, and this is my fault, you guys, that I was trying to read my writing. This should be 200 divided by 114. Sorry, I calculated my seconds wrong. Okay, now this video is going to end and I'm going to start another one to continue this. So don't be freaked out whenever it stops.